interference is a calculation of a path difference. Now here we have calculated the path difference between two waves is d sine theta. Now let's move into calculation of position of minima and maxima. Now when I say maxima, it means we are interested in the points of constructive interference. We know from the basic theory of interference, at all points where constructive interference will take place, path difference will be integral multiple of wavelength. So we can write for maxima the condition will be d sine theta is equal to n lambda, or we can write sine theta is equal to n lambda by small d. Now this equation gives angular position of all maxima on the screen, and n here is representing the order of maxima. Now when we take n is equal to 0, it is referred as 0 order fringe. When we take n is equal to 1, so it is representing the first maxima. N is equal to 2 will be representing the second maxima, and so on. N is equal to 0 gives us a maxima which is known as 0 order maxima or central maxima, we simply refer it. That is, it is a point on the screen where path difference is 0. It is very clear from the geometry of the arrangement, it will be the central point of the screen. It will be just in front of S1 and S2, and it will be a point which will be symmetrically located from S1 and S2, so that the path difference between the waves coming from S1 and S2 will be 0. So students, we have to remember this path difference expression and the condition for maxima, that is sine theta is equal to n lambda. N is the order of maxima, and when n is taken as 0, it is known as 0 order maxima, or it is known as central maxima. In fact, central maxima is a point on the screen where path difference is 0. Now we can have the positions of maxima in terms of linear distance from this central maxima. Let's say the distance of point P from the central maxima is y. We can write the value of sine theta, which will be same as that of tan theta. So we'll have y over capital D is equal to n lambda by small d. So we get the position of nth maxima as n capital D lambda over small d. Now here, student, we have to remember one thing which is very important. We are using the approximation, that is sine theta is equal to tan theta, and we know that when we have such situation, sine theta will be same as theta. Now sine theta will be same as theta. This approximation demands explanation, and it deserves our attention, because in IIT there have been many problems which have been asked based on the concept of sine theta is equal to theta approximation. Most of the students, they are under impression that when theta is very small, then only we can use this approximation. That is okay, but let's analyze this approximation more closely. Now on close examination, you will find that this approximation can be used safely up to 30 degree. Just to convince ourselves, let's verify this approximation for the situation when angle is 30 degree. We know that sine 30 degree is half, that is 0.5. Now when I write theta in terms of a radian, because when we write sine theta is equal to theta, here theta has to be taken in radian. Now 30 degree when converted into radian is pi by 6, and we know the value of pi is approximately 3.141592. Now when we calculate pi by 6, and that is 3.141592 divided by 6, it is approximately 0.5. So we can see the approximation can be used safely up to 30 degree. So the linear position of all maxima can be summarized in the expression that is yn in subscript will be equal to n d lambda by d, where n is the order of maxima, that is first maxima, second maxima or third maxima. And remember, n is equal to 0 will give us zero order maxima or the central maxima.